Today we explore why faster-than-light travel seems impossible in the first place. According to the theory of relativity developed by Albert Einstein, the speed of light is the ultimate speed limit of the universe. The faster you try to go, the more energy you need. And as you approach the speed of light, that energy requirement rises toward infinity. In simple terms, no matter how powerful your engine is, you can never push a spacecraft past that limit. That's why, for over a century, scientists believed interstellar travel within a human lifetime was simply impossible. But in 1994, a young physicist proposed something extraordinary. Miguel Alcubierre suggested a solution that didn't try to move a spacecraft faster than light at all. Instead, his idea, now known as the Alcubierre drive, would move space itself. The concept was simple, yet mind-bending. Compress space-time in front of the ship and expand it behind. The spacecraft would sit still inside a warp bubble, while space carried it forward. Locally, the ship never breaks the speed of light. But from the outside, it could cross vast distances faster than light ever could. What made this idea so shocking was not science fiction, but mathematics. The equations from the theory of relativity actually allow space-time to bend, stretch, and move in unusual ways. When Miguel Alcubierre applied these equations, he found a solution where a warp bubble could exist without violating any known physical laws. Inside the bubble, the spacecraft obeys the speed limit. But the space around it does the traveling. It was a moment when physics allowed something that sounded impossible, at least on paper. There was, however, a serious catch. The Alcubierre drive required a form of matter or energy that we have never seen in usable amounts. To bend spacetime this way, the equations demanded negative energy, often called exotic matter. Early estimates suggested the amount needed would exceed the mass energy of entire planets, even stars, which meant that while the math allowed warp travel, the universe did not seem willing to provide the ingredients. For years, this is why the idea remained closer to science fiction than engineering reality. Decades after the original proposal, physicists began revisiting the idea with fresh mathematics. By refining the shape of the warp bubble in the Alcubierre drive, newer models showed that the required energy might be dramatically reduced. Not eliminated, but reduced from impossible to merely extreme. Some researchers even point to tiny quantum effects, like those seen in the Casimir effect, as hints that negative energy densities can exist in nature. Suddenly, warp travel shifted from breaks physics to demands physics we don't yet control. Even if the refined models of the Alcubierre drive reduce the energy demands, building such a system is far beyond today's engineering. We would need the ability to shape spacetime itself, to create, control, and stabilize a warp bubble around a spacecraft. That means mastering forms of energy and gravity we currently only describe with equations. It's not a problem of rockets or fuel. It's a problem of manipulating the fabric of the universe. And that is a level of technology humanity has not yet reached. If a spacecraft could ride inside a warp bubble created by the Alcubierre drive, the journey would feel strangely calm. There would be no crushing acceleration, no sense of extreme speed. Inside the bubble, the ship is almost at rest while spacetime moves around it. But outside, the stars would appear distorted, stretched, and curved by the warped geometry of space. From the traveler's perspective, vast interstellar distances could pass in what feels like a short trip, while never locally breaking the cosmic speed limit. Despite the elegant math behind the Alcubierre drive, many physicists remain cautious. The idea has never been tested experimentally. We do not yet know how quantum physics and gravity truly fit together. Some calculations suggest instabilities could form at the edge of a warp bubble. Others question whether negative energy can be produced in the quantities required. In science, Permission from equations is not the same as permission from reality. And until we understand spacetime at a deeper level, warp travel remains a fascinating possibility, not a proven path. So, have we discovered a real way to travel faster than light? Not yet. But the idea behind the Alcubierre drive shows us something important, that the universe may allow more possibilities than we once believed. What was once pure science fiction is now part of serious scientific discussion. And maybe, one day, the boundary between imagination and reality will finally disappear.